Welcome to the session. My name is Victor. I work for CloudBees. You know who we are, so I won't go deep into what we do. I'm also very close to the Docker folks. I work quite closely with them. A couple of books, nothing to marketing now. So what we're going to speak today, what I'm going to speak today, is how we can approach continuous deployment using Jenkins, of course, and leveraging the advantages that Docker provides. Right. So we're going to go briefly through Docker. We're going to briefly define what continuous deployment is, and finally, how we can do those things through Jenkins. So let's start with Docker. Any of you using Docker in production? Lower your hand if it's not in production. Doesn't count if you play with it on your computer. So kind of 1/4 or something like that of you use Docker in one way or another. It's increasing drastically because when I asked this same question this time last year, only a person or two used Docker. Its adoption is getting really fast. So we are not anymore talking about Docker as engine. We're talking about a whole ecosystem that we are trying to leverage today. And not all of the elements, but some of the important elements of that ecosystem is Docker Engine. We use Docker Engine as a software, let's say, a service that allows us to operate our containers in the way we see fit. Then there is Docker Machine. Docker Machine is, let's say, a very light virtual machine that allows us to run, to simulate cluster on laptops, allows us to provision AWS VMs, if that's what we want, Azure, not CloudFormation, Digital Cloud, and basically allows us to either run cluster on our laptops or to provision our real machines with Docker. The next one is Compose. Those of you who played with Docker most likely use Compose. Compose is used to define in a declarative way what would normally be commands and arguments that we run when we execute Docker. Docker Registry, for those of you who don't know what it is, it's equivalent to what would be Maven repository. That's where we store our images and the place from which we retrieve images or pull them. And finally, Docker Swarm. So I will try to go briefly, very quickly through those things because I'm trying to focus today more on continuous deployment, and you can get much better informed about Docker afterwards. But in a nutshell, as I said, Docker Engine we use to run containers. And the reason why we like containers so much, or at least one of the reasons, is that containers provide a certain level of, not certain level, they provide us immutability, meaning that once created, images are unchangeable. They're going to be exactly the same no matter whether you run them inside of your laptop, on your staging environment, production, cluster, doesn't really matter. It's always the same, which gives us a huge benefit when doing continuous deployment because we know that what was tested on one machine will run exactly the same on another machine, assuming that the scripts that we use to run containers do not introduce any change. It provides a certain level of isolation, and this is usually where people get confused. They think that it provides the same level of isolation as virtual machines, which is not true. It does not isolate physical resources, but it does isolate processes, meaning that we have immutable way to run our applications that are process-wise isolated from anything else in our servers, which again provides quite a huge amount of benefits. It's very fast. You're going to see I'm going to set up the whole cluster in a minute, and I'm going to, even on my laptop, run the whole configuration deployment process in a matter of seconds or minutes. It's very, very fast, much faster than anything else we experienced before. Assuming that we change the way how we architect our software, which is a separate discussion, I think. It is very lightweight compared to virtual machines. It uses much less resources, and that's also one of the reasons why it's so lightning fast. It's self-sufficient, meaning that when you deploy your application in a container, if done right, you don't need anything else running on that server. They're completely self-sufficient. They're not, containers are not a single jar or var or whatever you're using. It's a whole server, let's say, everything you need, a certain application needs. And finally, we're still not there, but we are moving towards a world where there is no real infrastructure, which puts a certain problem with vendors of provisioning and configuration management tools, but it's not actually, there is no infrastructure, but infrastructure becomes so much simplified and less dependent on what we do than we had before. And the Docker machine, as I said, it's a very lightweight VM. It's optimized for Docker. It's probably, if you're looking for OS where you want to run Docker, Docker machine is probably the way to go, simply because it's everything that is not needed is removed, making it much more lighter and much less vulnerable than OSs that you use today, like CentOS or Red Hat or Ubuntu, whatever you're using, especially Windows. And of course, we can use it with almost any provider, VirtualBox, AWS, Azure, no matter what. Almost all of them. Next, Compose. The reason why I like Compose is because my memory is failing me. I don't like memorizing commands. I don't like memorizing arguments. And Compose allows us to specify everything we need related with containers in a very declarative way. YAML format, it cannot be easier than that. Very useful. And also it groups services into projects. Now, for those of you who do follow Docker releases, you might also know that Docker Compose is scheduled to die. But we won't go into that now. So, and then next one is Docker Registry. Simply, just like your artifact that you're building today, it needs to be stored somewhere so that it can be recuperated from that place. And that's Docker Registry. There are many flavors, many vendors. You can use free one, like private registry. You can use Docker Hub, that is public. You can use Docker Trusted Registry, that costs a lot of money, or JFrog, or quite a lot of solutions over there. And finally, Docker Swarm. Docker Swarm will be actually the main subject of what I'm going to try to show you today. Docker Swarm is a way to schedule your services inside of your cluster. Right? We're not deploying anymore to a specific server. We're not saying, I want my service to go to a server called Garfield. We say, I want my service to be deployed with this number of instances inside of a cluster. I don't care where. Swarm is going to figure it out. So we use it for deployment. We have very advanced networking. I'm going to show you very soon in a practical terms. It provides failover, meaning that your application, when it fails, it will be redeployed somewhere else, and all those things. So now, I don't really actually like to talk much on slides, so I'm going to start almost immediately with a demo. So on my laptop at the moment, the only thing I have are 5 Docker machines created, right? They don't have anything inside except Docker engine, right? They're completely virgin, nothing. So I'm going to tell my laptop that I want to use a machine called Swarm 1. Can you see this? Shall I make it bigger? You're okay? Excellent. And I'm going to run something called Visualizer so that I can show you on a screen in a graphical way what's going on. Sorry for that. Still nothing to memorize. So this is my cluster at the moment, right? Meaning that I have no cluster. I don't have a single server in a cluster. I have nothing. Completely empty. Blank screen. So the first thing I will do with the cluster is that we run something called Docker Swarm init and say, I want you to initialize the cluster. I want you to be the first server in this cluster. It's a single command, nothing else, saying Docker Swarm init, this is the address, this is your own address, go. Right? It gives us some security tokens. I'm not going to go into that, but what is important that if I go back to Visualizer now, this is my cluster, right? I have one server there running. And it's still not a big deal. A single server cluster is really not very usable, so let's try to increase that cluster to more places. And the way how we do that is I'm going to tell to auditor servers, Docker Swarm join, this is your token, this is your address, and that's all I have to do in order to add two servers to the cluster, right? It's the message I'm trying to convey, it's extreme simplicity, what we are trying to accomplish with those tools. So let's add 2 more servers to the cluster. If I do this, excellent. So now my cluster looks like this, right? I have three nodes in my cluster, but nothing inside, right? And if you're like me and you don't like UIs, you can do everything from command and say docker node ls, and it gives you the list of my cluster. So there are 3 nodes, as you can see, Swarm 1, Swarm 2, Swarm 3. One of them is a leader. All of them are reachable. I can send command to any of the nodes of my cluster. So now the next thing I need, I already explained that there is something called Docker registry. I want to create my first service. Service is a concept in Docker Swarm that it's not imperative. With services, we tell Swarm the desire that we have, the state that we want, right? We don't tell Swarm what to do. We tell him what we want to be the state of something, right? In this case, I'm going to tell Docker service create. This is the name, registry. This is the port I'm exposing, 5000. I want to share current directory, pwd, on a host with the directory in container, so that I persist my files. This service is going to occupy 100 megabytes of memory, so make sure that actually you put it somewhere where I have enough memory available, and the name of the service is registry, right? And that's it. I created my first service. The fact that I created a service does not mean that it's running. It's just that it will run when Swarm manages to do that, and it actually already did it. And you can see that I have my first service running already for 16 seconds, right? And as you can see there, Swarm decided to put it on a node called Swarm 1, right? It could be anywhere else. It could be on Swarm 2, Swarm 3. We don't care anymore where things are running. We know that they're running in a cluster because cluster is a single entity now, right? It's not each server anymore. It's a cluster as a group of things, group of resources. So let's start with a bit more interesting services. I'm going to create first something called network. I'm going to create 2 networks, actually. I want to create a network called proxy, a network called Go demo, right? And what that really means that Docker created 2 networks inside of my cluster, and you will see soon why. Networks are probably the essential now thing for managing a cluster. So let's continue with another service. I'm saying Docker service create. This is this is database, Mongo database. And it's going to belong to the network Go demo. The image is called Mongo, because that's official MongoDB image. And what you will notice is that I did not expose any ports, right? So my database is completely inaccessible to anybody, literally anybody. So there is absolutely no way that you can now send a request to that database and get any response, except if you're inside of the same network. Right? And the network is called GoDemoDB. The network is called GoDemo over there. The reason why I do that because we are trying to restrict who can do what, right? Not in a human way of restricting, saying that you cannot actually do commit, but in infrastructure way. To demonstrate services, let's see first to list my services. If I look at my services, you can see that I have 2 services, registry that I ran before, GoDemoDB that I just run. Both of them are running one replica, and they're somewhere inside of a cluster. Now let's create another service. I think that this is going to be the last one. This is my backend. It's a backend that exposes an API. It belongs to the network Go demo. It also belongs to the network called proxy. At the end is the name of the service. Now this is an API backend, meaning that the purpose of this backend is to allow external users to send requests, do something, whatever, normal things that we do with the APIs, right? But you will notice that, again, I did not expose any port. This service is still inaccessible to anybody. But what is very important is that those two services, GoDemo and GoDemoDB, work together. They form one application, right? I have a backend that needs a database, and they need to speak with each other. And that's the reason now we come to the first purpose of creating networks, is that since they both belong to the GoDemo network, they can speak with each other, and nobody can speak with them outside of the network. And if that wouldn't be true, my service is coded in a way that it would fail if it cannot access the database. And as you can see, actually, it's running already for a minute, so obviously it can speak with the database. It does not require any configuration, anything. The only thing that it needs is the environment variable over there called DB that gives him the name of the service it needs to speak with, in this case, GoDemoDB. And from there on, my service uses DNS called GoDemoDB to communicate with the database. So the last piece of the puzzle is that now, since this service is inaccessible to anybody outside of the network, I need some kind of reverse proxy. I'm going to create my last service, I think. And this is actually the first service that exposes any port. It exposes port 80, 443, HTTP, HTTPS. 88 is internal thing, not really important. But what is really important is it belongs to the network proxy. There's the same network where the GoDemo belongs. So because we want those two services to speak with each other now. And let's see whether it works. Right, if I list processes of my service, you can see that my proxy is running already for 4 seconds, so everything is okay. I can configure my proxy remotely. That's still okay. And I can send a request to my service, right? If my service would not be accessible, it would not return 200 HTTP. I get hello world, it all works, right? But what you will notice, if I go back to the proxy, my proxy is running on Swarm 2 node over there, you can see. But I'm sending requests to Swarm to a completely different server. Because we don't even need to know where our services are anymore, because Docker networking that I'm using make sure that actually every exposed port is available on any single server. Wherever the request comes, Docker networking is going to redirect it and load balance across all the services that belong to it, in this case, proxy. So, and the reason why I'm telling you all that is because I want you to have a very brief overview of how I would create and deploy services manually before we go into how I would do it with Docker. So that was a very quick overview. So let's see, continuous deployment, right? Any of you doing continuous deployment? Anybody deploying every commit to production? Huh? One. Excellent. 2. Okay, so what we want with continuous deployment, shame on you, first of all. We check out the code, we run some tests, we build something, we run functional tests, we push it to the registry, we deploy it to some server, some cluster that looks like production, run production tests, and deploy it to production for real, and run production tests, right? Everything automated. It's not really magical. It's just having a really good test coverage and having the application being scripts that are capable of deploying our application on every commit. However, I have extra requirements. Right? This is official, right? If you go to Wikipedia, you will find more or less these steps. But I want to have freedom, right? I really want to be able to code in any language. I hate when some organization tells me, you need to work only in Java, right? Because Java might not necessarily be always the best choice for every service that I'm doing. And even if I want to use always Java, and I'm using Java only as an example right now, I don't want to be restricted to certain JDK, to certain version, or any other thing, right? I want freedom to be able to do my project in the best way possible that I think I can do. I don't want to depend on any single framework. I don't want to depend on anything like that. And I don't want to have dependency on any infrastructure, right? I don't want to wait for a month until some infrastructure department creates my servers. I don't want to wait until they set up something. I don't want to wait for any of those because we're trying to be fast to the industry, right? We're trying to release as fast as possible. And it's okay if you don't want to release fast, but then you cannot put continuous in front of your processes, right? Continuous means all the time, continuously. Immutable deployments, already explained. And I want things to be exactly the same no matter when, no matter where. And I want minimum time in between steps, right? No handovers. And everything automated. We are all on this conference because of Jenkins, because we want to automate stuff, right? And finally, freedom to innovate. So why do I want those things? Because I'm impatient. I'm very impatient. I don't like waiting for anything, right? They usually kick me out after some time, but that's okay. I hate handovers. I really dislike departments that I need to hand over my stuff to somebody else who's going to give it to somebody else who's going to give it to somebody else until actually 3 months pass and my service is still not in production. And I'm asocial. I don't like to depend on others. And I hate doing things over and over again. So those are my motivations for going something like this. So the tool, part of the tools that we've been using, and the reason why we are all here is Jenkins. I'm not going to preach you know what Jenkins is. It's continuous integration, continuous delivery, continuous deployment. It's bloody, it's orchestrated. It's really, really, really awesome, right? Or I assume that you wouldn't be here if it isn't. So let's see how I would run Jenkins after this quick overview, right? You're probably used to run Jenkins on a dedicated server. I don't do that anymore. What I do is I'm going to create a directory. Nothing to care about right now. I'm going to use the same logic that I used before. I'm going to create a service called Jenkins somewhere inside of my cluster, right? I'm going to tell Jenkins, these are your ports. I want you to use 300 megabytes of memory. Run somewhere. I don't care where, right? And I don't care where because let's assume that I have a big cluster. I don't even know how many servers I have, and I don't even know how many servers I'm going to have tomorrow. And if I look at my services, Jenkins happens to run today on Swarm 1, right? That's simply where Swarm decided to put it. And finally, before we come into very cool stuff, let's see whether this works, right? If I open the Jenkins is a bit sluggish today. It requires a few minutes. Okay. I'm going to set it up very, very quickly. I don't want to waste your time. In order to use Jenkins 2, right? You know that when you set up Jenkins 2, you need to get a temporary password. I hope you use Jenkins 2 because you didn't. You should. So I'm going to register my Jenkins instance. I'm going to install suggested plugins. And I'm going to hope that network works today because it didn't work yesterday. And hope it's not going to last more than 50 seconds because you heard I'm impatient. Let's see. It's going to start running soon, right? Somewhere inside of my cluster. And by the way, if you go back to my cluster, this is how my cluster looks like right now. There are services distributed all around, right? It's still a small cluster, but database is running over there on Swarm 3. My service is running on Swarm 2. My proxy is also running in Swarm 2. Jenkins is running on 1. Registry, just Swarm puts it, I don't care anymore where, right? Because it knows better than I do where should things go. And Swarm is still slow. It will start soon. Yes, questions. This is a good, what? I have no idea what you asked. Sorry, I need to come closer to hear you.
I was wondering how does fault tolerance?
You're impatient like I am. You need to wait for 1 more minute for the answer to that question. That's the next slide, but I need to wait until this finishes. Yes, please.
Your clusters contains 3 machines actually.
Yes.
So where the data will go, like in real environments, like currently all the machines are in your local laptop, right? But in practical, it might be 3 VMs or 3, whatever 3.
Yes, or 300, or 3,000, or 3 million, yes.
you are running a stateful applications here, which is Jenkins.
Yes.
In that case, how the data.
So the question, while we're waiting for network to start working, was what happens with my data? What happens with my data? If you go back to my command, you will see this line. I'm mounting a current directory /docker/Jenkins on my host to be the directory var Jenkins home inside of container. And this is my laptop, so there was no need, but this would normally be, if you're a beginner, this would be NFS. If you're a bit more advanced, this would be Flocker, or one of those tools that actually manages distributed load. But the point is that you can expose any directory inside of container to the host. What you do with those files on the host and how do you preserve them, it's a different question, not directly related with Jenkins, but you can start with NFS, for example, and probably you would have 2 NFS servers and do rsync between 2 of them and then go into more advanced topics. Does that answer your question? Okay, is not an answer, yes or no? I'm kidding. Okay. Finished, excellent. I'm very happy today. It was better than yesterday.
Shared storage is a requirement.
It's a requirement for Jenkins, depends from case to case. For databases, in most cases, it's not. For example, because databases have their own mechanisms to synchronize themselves. For example, for MongoDB, you would use replica sets over multiple instances, so that multiple instances have the same data, not related directly with Docker right now, but if you have multiple instances of your database with synchronous data, then it doesn't matter whether you persist it on a host or no. And you don't do backups of a database by doing copy anyway, because that would provide corrupted backup. Does that answer your question? Excellent. So I have my Jenkins, right? I'm very happy. And the last thing before I continue, I'm going to install a very cool plugin called Jenkins Swarm. In this case, it has nothing to do with Swarm, Docker Swarm. It's a way how I like to create my agents. Any of you use Jenkins Swarm? Oh, that's a better answer. Excellent. Some of you did. It's a cool plugin. Not necessarily always the best choice, but a cool plugin. So let me install it. And you will see soon Jenkins Swarm in action what it does. Excellent. So I have my plugin installed. Everything is great. So going back to the lovely girl over there asking about failover, let's kill Jenkins. Am I allowed to say, marketing department, am I allowed to say kill Jenkins? I don't know. So I'm going to kill Jenkins. It's a command to kill Jenkins, a bit of shell script, nothing to worry about, so no need to go into details. What is really important is that if you look at it, Jenkins disappeared, right? There is no Jenkins, there it is again. It's like a magic trick, right? And what happens is that if you remember from what I said before, we do not tell Swarm what to do, we tell Swarm what we want it, what is our desired state. And I told already Swarm that my desired state for Jenkins is to run one instance, always. If Swarm detects that that instance is not running, it will run it again. And if it fails again, it will run it again. And if I kill the whole server, it will move everything that is running on that server somewhere else, right? That's the difference between being imperative and expressing the desire. So if I look at now, if I remember correctly, Jenkins was running on Swarm 1, on Node 1. Now it's running on Swarm 3. And you can see that the instance on Swarm 1 is in a shutdown state. It failed a minute ago. And now for 57 seconds, 3 seconds later, it started running somewhere else, right? And if you don't believe me that it's running, let's start Jenkins and confirm. Patience is a virtue. Yes, a question. You need to yell. I'm sorry. Huh? I mounted the volume, the Jenkins home to the host, so actually the files are still there, right? And that's the very easiest way to do it. It could be NFS. Or you can use Google afterwards projects like Flocker, which do it in a much fancier way. But the point, no matter which tool you use, that you can expose something from a container to be saved on a host. So let's see. I'm going to create a second cluster, right? I have one cluster now. I'm going to create a new cluster. I'm going to introduce this cluster. I'm going to create a directory called workspace. I'm very, very insecure person. I'm give it permission 777. We should never do that in production. Really, don't do it ever. And so, in a new server, I'm going to say, okay, can you become a new cluster, right? I want a second cluster. And this cluster I'm going to call, the first server is called Swarm Test 1, right? I have a new cluster. And let's visualize that cluster very quickly. And open it in browser. Everybody likes to see pretty colors. It's always cool. So this is my second cluster, right? What I'm going to do with second cluster, I'm going to use it as for my Jenkins nodes, right? I don't want my builds and tests because the first cluster is production, but I want my second cluster to be isolated from the first cluster because I'm going to do some things that are really nasty. So what do I do? I'm going to create a directory called Docker Jenkins Workspace, going back to your question, so that I want to persist the state of my agents as well. And I'm going to create a new service. This time I'm going to run Jenkins Swarm, right? It's the same Jenkins Swarm plugin that we ran before. It's just that I have it in a container because I like running things in a container. There's nothing else special. I'm telling it that I want 5 executors for this agent. And one important thing that I didn't show you before is that I'm saying that this should be in a global mode. You will not see a difference yet, but soon I will show you why global mode is so cool. So if I look at my services, let's see, is it running? It's running already for 4 seconds. I'm lightning fast today. So if I look at my Jenkins, let's see, do I have my agents running? Yes, I do. Here it is, right? That's all I need to run an agent, because the agent is out, registered itself into master. I don't like UI, except when I'm showing you guys things. I normally don't enter there, because UIs are evil. So let's see. Shall I create more agents? Do you want more nodes in a cluster? Let's create more nodes in a cluster. That was a rhetorical question. So I'm going to enter this directory. I'm going to create a directory called workspace. I'm going to run Docker Swarm join. I'm going to say second server, join the cluster, right? Join the cluster, my test cluster, and be happy about it. And now but pay attention that this time, on this second time when I created I did a new server to the cluster, I did not say anything about Jenkins service. I did not run a new service. Why? Because that's about the global mode that I showed you before. Because when I run a service in global mode, that means that service is going to run on every single node of my cluster, no matter whether it's created a second ago or a minute ago. So every time I create a new server, automatically the service will be running there without anybody asking anything. So I have my Jenkins agents running now on two nodes, right? And if you don't believe me, let's open Jenkins again. UI, we like UI. Go ahead. 2 nodes, right? Sorry, not 2 nodes. 2 agents running there, getting some really weird names. We don't care about names anymore. So let's see. Now that we have our master configured, and that it's fault tolerant, meaning that it will work no matter what. You can destroy fault server. It was still working. We need to do a bit of configuration. Configuration is good if it's not done often. Let's see. Configuration, are you working? Configuration, yes, configuration. I'm going to put an environment variable. This is my own nested thing. The reason why I'm putting environment variable, I forgot the name, yeah, prod IP. I'm going to tell Jenkins where is my first server, production server. I need to know the IP of the server, of any of the nodes. Doesn't really matter which one. So I'm going to ask what is the IP. This is the IP, right? So I'm going to configure, create environment variable with this IP. I'm going to create, also give it a name, prod name, production name. Production name is Swarm1. This is all the configuration I need. No, I don't want this. Sorry. Save. Excellent. I'm going to run registry so that I can push my containers there and pull them from there. It's already running. I'm like, no, it's not. It's preparing. Now it's running. Excellent. So now that I have my 2 clusters set up, I have everything set up, I have Jenkins running, it's always running no matter what happens. Now we can talk about continuous deployment. Continuous deployment means no humans, none of you, doing any manual actions, right? And there is no exception to that rule except when something goes wrong. So that means that automatic. Everything that I spoke about, all the steps that I spoke about before, they should be fully automatic. So let's create a Jenkins pipeline job that will do all that for us. I'm going to create a new job. I'm going to call it call demo. I'm going to say it's pipeline. I'm going to click OK. And I'm going to go to the pipeline. Are you using pipeline? No, go, please. Yes. Fake it, at least. Say you are. I'll create a job called I'm also faking it. It seems like I know what I'm doing. I'm copying and pasting things from the presentation. I'm going to tell, okay, this is my code, right? This is my Git repository. I want you to check out the code, right? I want you to run some unit tests. I'm running everything as a container, right? My unit tests are defining some container. Nobody cares why. All we really care is that they're called unit. I'm going to build a Docker container. I'm going to go to a separate environment and set up some staging dependencies. I'm going to run MongoDB and my application that was just built. That's what I do with Docker compose command. And once I have everything running, I'm going to run my functional tests, call them like that. Again, it's just called staging. That's my container name. And at the end, no matter whether it works or no, I want to destroy everything, right? I'm a very destructive person. When I run my tests, I run my databases, I run all the dependencies, I run my tests, and then I destroy everything so that I can free my resources for something else. I don't want to waste resources. I don't want things running if it's not necessary. So I want to say Docker compose down. Down means destroy everything, right? So now I finished with the staging environment. I can publish it to Docker registry. And finally, I can update my service, because Go demo is already running in a cluster. I showed you, I did it manually. That was very awful, but that's how it goes. And now I want to deploy a new release, right? And the way how we deploy the new release, first of all, we don't want any downtime, right? We don't want to stop what we are doing and then deploy a new release, because that's downtime, millisecond, second, minute, nobody knows. It doesn't matter, but it's downtime, and we don't want it. So we want to update our service. If we want to update it in a way that there is no downtime, that means that if you use Docker service update, and we have multiple instances, it will update one instance, and then the second, and the third, no matter how many instances, it will update them one by one, so that few instances are always running, right? And finally, after I run it in production, I want to run some production tests. And this is, again, the same thing. Always Docker containers, just that this time it's called production, right? So let's see whether it works. It never works from the first attempt. This will be very surprising. Let's see. So yeah, soon it will work or it will fail. Let's look at the logs. Okay, so I checked out my code. I'm creating my network, running my test. This service, by the way, is written in Go, so I need the Go library there. It's running inside of containers, so I'm not polluting my server. And I'm going to destroy it afterwards. Slow network. It's going to start soon. Or if you don't like logs, if you're one of those guys that like colors and stuff happening, then you can look at this. Depends on a preference. Let's see whether it will work. It's still downloading libraries. Luckily, Go is much lighter than most languages, so it will be less painful than most others. But still, very slow Wi-Fi here. Let's see if I can accomplish the whole continuous deployment even with those slow Wi-Fi to be less than 3 minutes. I hope I will. Or not. This is the time for questions while we're waiting for Wi-Fi. Yes, please. Yes? Yes. Okay, I'm going to repeat your question. So it's not a question, it's a statement that my solution is very similar to what Kubernetes does. And it's absolutely true because Docker Swarm and Kubernetes and Mesos, they all try to solve the same problem. And the problem is how do we schedule and orchestrate our cluster. So yes, you can use Kubernetes or you can use Swarm or you can use Mesos. They have the same 5 minutes. Wi-Fi is not working. I'm sorry. So yeah. We can, if you want, I don't think that we have enough time, but if you want afterwards, we can discuss the difference between Swarm and Kubernetes, and I can tell you why I dislike Kubernetes. Anybody who likes Kubernetes here? I'm sorry for that. But yeah, they have the same objective. Any other question while we're waiting for this to work? Yes, that's partly true. It's not going to be deprecated. It's going to stay on a single server cases. So when you run a single server, you want to run your containers. Docker Compose continues being, it will continue being useful, whatever you're doing now. But with the new Docker Swarm, which is what you should be using, unless you're using Kubernetes or Mesos, to deploy to your cluster, it does not support Docker Compose format. However, it's currently in experimental stage. An option in Docker Compose to convert it to Docker service format. So you'll be able to convert your Docker Compose files to JSON. It's called bundle. Is this work? It's not working. I have 3 minutes. Any other questions? Yes, please. Wait. You either need to yell or I need to come. Tell me.
Is there a way to declaratively do whatever you've been doing in terms of provisioning Jenkins? Is there a declarative format? I know it's probably not related to what you were doing, but...
Declarative format in what way?
Of provisioning Jenkins to a known state instead of preserving state and then restoring from...
Okay, yeah, so the question is whether there is a way to actually provision Jenkins in a more automated way than clickety-click, right? There is. Depends on what you need to do. There is an API that you can use. You can plug in Groovy you can execute Groovy code as well. And you can use XML. Or the fourth option is that you can actually create XML files because everything ends up being, the state is actually a file, in case of Jenkins. Some things are easier than others, but we can speak about details later if you want. Yes, please. Is this working? Sorry. No, it's not. Okay.
What tagging strategy do you like to use with your Docker?
Sorry?
What tagging strategy do you like to use with your Docker registry?
Yeah, so the question is what tagging strategy format I'm using when tagging things before I push them to registry, right? That was the question. Yes. I tend to simplify things greatly. So I tend to use, I tend to use major release, which is fixed, plus build number, Jenkins build number. So that works well for me, but anything else would be okay for you as well. If you look at, if I go back to my pipeline job, you will see that in this specific case, this is what I used, 2.build number, right? I'm very much inclined towards continuous delivery deployment, meaning that I rarely deploy anything that is not the last one. So I don't have a strong need to go crazier than this. But basically, usually, assuming that we're talking about versioning from inside Jenkins, we'll probably use some combination of build number and maybe a few other environment variables. Does that answer your question? Git? Yeah, that would work as well. Let's see whether it works. I have probably 5 seconds or something like that, guys, no? You need to give me your hand something. I don't know. Is that a 5 minutes hand left? Okay, this is not working. I'm giving up. Another question. Who lifted a hand? Somebody behind. Yes, please, go.
Maybe off topic, but I was wondering if Jenkins is going to come up with any plugin or anything that can sync jobs between two different masters. If you have multiple masters and you need to import jobs and you want to have the same exact configuration between two Jenkins, currently it's like manual process.
Yeah. So the question is whether you will be able to scale Jenkins to multiple masters that share the same jobs, right? Yes, I'm not allowed to tell you the date because I don't know it. And even if I would, I wouldn't. But if you were the keynote, I think that Kosuke said that was one of the plans to make actually Jenkins master be spread across multiple servers. And he didn't mean to spread multiple separated masters, but let's say the same master being run on multiple, and then it would share jobs and all those things. I don't know when, but not today. Okay? Any other question? Imagine that this worked, and actually I finished my job. Nobody? Do we have some time? No. 3 minutes, 2 minutes late. Okay, one more question, and whomever asks gets a free Jenkins for life. Who? You? You want a free Jenkins. Excellent, bravo.
Does Docker Swarm support IP per container right now, or the Docker networking?
Which containers?
Any spinning up Docker containers, either in Swarm, whatever, does that support IP per container?
IP?
Per container?
IP per container?
Yeah.
Yes. Every container, for example, in case of Swarm, to speak about latest, depends on the mode you're running. Every server gets an IP, right? If you remember when I spin up a database, it got, first of all, the DNS, which is the same name of the service, gets its own IP, and that's a service. And now within a service, each instance also gets an IP. So for example, if I scale it to 5 instances, I would have 6 IPs. One is the IP of service itself. If I call the service, then actually Swarm networking is going to load balance across all instances, right? Do round robin. But if I really want to go crazy for unknown reason, then I can actually fetch each individual IP and go there. You do that if you want service IP, you just use the DNS, which is same as the service name. If you want all the IPs, it's called tasks.name of the service. So tasks.godemodb. Any other question? Anybody else wants free Jenkins? This is not working anyway. Yes, it's the last one. Yes, service discovery is now it's now integrated into Swarm. So actually, Swarm uses internal, or Docker Engine actually uses internal service discovery. Now, depending on what you need, in most cases you don't need anything else because actually you discover your services by knowing the name of the service. But if on top of that you want to use for some other purposes, and I often do service discovery, then I would set up, in addition to internal service discovery, I would set up Consul or etcd. Please don't use Zookeeper. Promise me that. Okay. And you're all good. Yay! Praise the Lord. I think we're finished. Okay, so guys, thank you very much for coming. I'll be outside. You can pick my brain, whatever you need. Thank you very much.